What's up everyone? In this video we're going to be talking about rotating different figures about the origin. So a rotation is probably something that you've seen a lot in your daily life. It's literally just a circular movement of an object around a fixed point. So tires rotate, the globe, the earth rotates, and if you guys look at the little gifs that I have on the left, we have that duck rotating at the top, and then we get a bit more geometric with that triangle rotating off of a grid. And then the last gif at the bottom is kind of what we're really going to be seeing. We're going to have different figures on the coordinate grid are going to be rotating around different fixed points. Now, when we rotate figures, their size and shape is not changing. So we're going to go back and relate that to a rigid motion. So a rotation is a rigid motion because the size and shape are not changing. Now for a rotation, we need to know how much we're actually rotating it, right? And it's not just how much we're rotating it, but we need to know the direction that we are going. So the standard rotation direction is actually counterclockwise. We can also rotate a shape clockwise as well. But if you take a look at this notation here, we're using a capital R as well. So don't get confused with reflections. Reflections use a lowercase r and rotations use a capital R. So make sure you're on your toes with that. And then the standard, again, rotation is counterclockwise. So if you see something like this, this means that we are rotating our figure 90 degrees. But then if you have a negative angle here, that's just saying that you're going to be rotating it clockwise. Now we're going to go through an example, and in this unit, or this lesson, we're only going to be talking about rotating figures around the origin. So we have triangle BCD, and take a second to pause and plot those out.
All right, we're going to be evaluating what actually is happening to a figure after it's being rotated. Now remember, for a rotation, you need two things. You need a center of rotation, and this is a point that is going to be staying the same throughout this rotation. And then you need an angle and a direction of the rotation. So typical angles are like 90, 180, 270, and 360, but we can go clockwise or counterclockwise. So in general, when we are rotating a shape, right? Whether it's a segment, a figure, what's happening here, and in this lesson, we're just going to be dealing with the origin, right? So the origin is our center of rotation, and that's the point that's not going to change. So I'm going to physically stick my pencil in there to ensure that it does not move after I rotate my paper around. Now, if we begin to rotate this triangle, you will see that as I rotate it, it's keeping that same distance from the origin for all the points, right? Now, what you'll see is I've traced the axes. Now, when my axes match up, that is going to be a 90-degree rotation. So right now, you guys can see this figure here would be the image of triangle DCB after a 90-degree counterclockwise rotation. Now, if we go and do another 90-degree counterclockwise rotation, we're going to keep going again until our axes match up. So that right here, if you take a look at our original triangle and our image, that would be a rotation of 180 degrees about the origin. Now remember, for the origin, that's the point that my pencil is in. That point is not moving. It's not going anywhere when I'm rotating my paper around. Now if we want a 270 degree rotation, we would keep going again one more time until our axes match up. So that right there is a 270 degree rotation of triangle BCD around the origin, or DCB. And then if we go one more time, you'll see that we land exactly on our figure, and that's a 360 degree rotation. Now what I also want to show you guys is that when your center of rotation is different, your figure is going to look different. So we dealt with the origin, right? But let's say, for example, I changed where the point that I'm keeping constant. So let's say I decide to put my pencil right here, or let's say right here. Let's say this was going to be my center of rotation. That's the point 4, 2, right? We're not going to really deal with this much this lesson, but just so you can get a visual of what's happening here, if this was my center of rotation, my figure is going to rotate in this way. It's rotating around that point. So every other point is changing except the center of rotation. Now, if our center of rotation was even a little bit different, let's say I chose this point D here. If that was my center of rotation, again, that's the point that's staying constant. It's not going to move at all, and your figure is rotating exactly around that point. Okay, so it's good to just have an idea of how the center of rotation affects your image. Now, This patty paper is great. It's wonderful, but the Regents exam doesn't really want us using that. But we can replicate that same idea if we just rotate our paper. Now, again, we have the same triangle. We have triangle BCD, and it wants us to rotate 270 degrees about the origin. So our center of rotation, again, is going to be this point 0, 0, and we want to go 270 degrees, just like we did in the other example. Now, instead of having this tracing paper, what you can do is you can put your point on the origin. Let's move this paper a little bit, because we're going to rotate it. So if your pencil's on your origin and you rotate your paper, so that would be a 90-degree rotation. That would be a 180-degree rotation. And then that would be a 270-degree rotation. So if we were looking at this axis straight on, we know that our points should end up somewhere here, right? So now exactly what we're going to be doing is pretend like we're looking at this straight on, and let's just count the boxes away that point D now ends up from our origin. So from our origin, we need to go to the left, 1, 2, 3, 4, 5, and we need to go down 1, 2. So now if I flip my paper back, again, we needed to go to the left 5 and down 2. So if I go to the left, 1, 2, 3, 4, 5, and I go down 1, 2, I end up at this point right here, which is going to be -5, -2. Now, if I do the same thing, right, so now this is our actual axis, but if I want to replicate that 270-degree rotation, 90, 180, 270, and now again, we're pretending like we just want to count how many boxes away this point here ends up from our origin after we do that rotation. So after we do that rotation, if we're looking at our axis straight on, to get to C, we have to go to the left, 1, 2, 3, 4, 5, 6, and then we need to go down 1, 2, 3, 4, 5, 6. So we have to go to the left 6 and down 6. Now if I put my axis back to its original place, again, we want to go to the left 6 and we want to go down 6. And that's going to be our C prime. This was our D prime. And now for B prime, we have to do the same exact thing. So again, I want to see where my image is going to end up, or where my figure is going to end up after a 270-degree rotation. It's going to look like something like this. So let's count for B now. For B, it's a little different. Now, from our newfound origin, if this was our actual grid, we have to go to the right 1 and down 1, 2, 3, 4, 5, 6, 7. So let's put our grid back, and we have to go to the right 1 and down 1, 2, 3, 4, 5, 6, 7. And there's B prime. So C prime we had at -6, -6. And then D prime we have at, D prime we already did. D prime is -5, -2. And then B prime is 1. And then how many did we go down? 1, 2, 3, 4, 5, 6, 7. 1, -7. Now, if we take our straight edge and we connect these points, we get something that looks like that. Now let's test it with our tracing paper. Let's see if that's where it actually ended up, but let's do it on the big grid. So if we take our figure here, right, and we rotate it 90, 180, and 270, our points should end up and if you draw heavily enough through this tracing paper, it will go through. But again, this is D prime, this is C prime, and this was B prime. Now, if we take a look at that, if you can see what I've just marked, it matches up exactly to what we did, right? So you don't need the tracing paper to replicate that, but it is a really good way for you to check your work.
Okay, so these are some rotation rules that you can remember, and these would work for any point, right? So if you have a point and you're rotating at 90 degrees, you can follow this rule here where you switch the coordinates and negate that value. If you have a point and you're rotating at 270 degrees, you can follow this rule, right? But it is a lot to remember, so you can get all of this done without remembering any of this, as long as you understand the concept of rotating your paper and finding the new location or finding where the point ends up. So again, just remember, for a rotation, you need a center of rotation, and that is the point that is not changing. That's the point that you are rotating around, and you need to know whether you're going clockwise or counterclockwise, and you have to know how much exactly you are turning your figure.